Our modern civilization commands hundreds of thousands of times more wealth and technological power than the most massive empires in history could have ever imagined. The average standard of living today is so high that even the wealthiest historical kings lived in relative poverty by comparison. Given the choice between a modern rented two-bedroom apartment and a sprawling 15th century French palace with no plumbing, no air conditioning, and a high risk of cholera, the apartment wins every single time. Comparing our global economy to those ancient empires is like comparing a jet engine to a donkey. We are operating on an entirely different level of complexity. But that complexity makes us fragile. A jet engine flies faster and higher, but one tiny flaw in its network of interdependent components can render the entire machine useless mid-flight. This extreme advancement is exactly what makes our society uniquely vulnerable to a sudden catastrophic collapse. In 1972, a team of researchers at MIT used a vintage IBM mainframe to test the structural integrity of this global machine. They built World 3, an early software model of the global economy, designed to push our usage of resources to its mathematical breaking point. The model reached a chilling conclusion. Our current system of growth is unsustainable and breaks down almost completely by the year 2040. This model tracked 5 specific variables: population, industrial output, food production, available resources, and pollution. These variables are completely interdependent. In a complex economy, you cannot change one without instantly affecting the other 4. Because they interact, they are prone to feedback loops, the same effect you get when you hold a microphone too close to a speaker and the system amplifies its own noise until it screeches. The economy works the same way. A drop in food production reduces the population, which lowers industrial output, which further drops food production. The system accelerates its own decline. To accurately predict the future, MIT had to account for these massive, cascading chain reactions. The researchers didn't just make one prediction. They tweaked the initial conditions to run multiple branching scenarios. In the top branch, the comprehensive technology scenario, extreme efficiency allows innovation to outpace resource depletion, resulting in a safe plateau. The middle branch shows a stabilized world. Here, humanity voluntarily slows industrial output to invest in renewables, completely avoiding a pollution spike. This stabilized model was considered the most optimistic and realistic goal for humanity back in 1972. Then there is the bottom branch, business as usual 2. This model assumes society changes nothing about its trajectory. In this scenario, pollution spikes while food and industrial production crash simultaneously. It is a total system collapse under its own weight. 50 years have passed since those models were built. We can finally answer which of these paths we actually took. A 2021 follow-up study by KPMG overlaid 50 years of historical data onto the original MIT models to audit our progress. The historical data points snap perfectly into alignment with the catastrophic business-as-usual 2 scenario. The audit revealed that we are hitting critical pollution and resource benchmarks years sooner than the 1972 math anticipated. Because these markers are appearing early, we are currently ahead of schedule for total societal collapse. While the KPMG data is alarming, the original MIT model has a major flaw. It held a highly pessimistic view of human innovation. History suggests that necessity is the mother of invention. Humanity innovates exponentially faster when our backs are against the wall. We see this shift now in the massive recent surge of renewable energy technologies becoming economically viable in the public market. By understanding these systemic feedback loops today, we have the agency to intentionally alter the variables before the system breaks. The MIT simulation functions as a diagnostic warning system that works. It gives us the data needed to identify the flaws in our civilization's engine while we still have the power to fix them.